Okay.
Yes. Yeah. Worksheet.
So here is what we are going to be using today. A long, long time ago, back when we did limits all the time, we talked about the limit as x approaches 0 of sine x over x. We also talked about that at the beginning of this section. If you look back at the beginning of the notes, we had theorem the limit as theta approaches 0 of sine theta over theta equals 1. And that's something that we can take as fact. Well, there is another result of that. If I said the limit as theta approaches 0 of sine 2 theta over 2 theta, that would also equal 1. As long as your argument and your denominator are the same, and they're both going to 0. So 2 times 0 is turning into 0, right? And 2 times 0 is 0. So if you have the form sine 0 over 0, and the argument and the denominator match, then we can still say it goes to 1. So we are going to use this today to simplify some limits. We will need these in the future, so we're working on just the limit piece today. So if I wanted to find this limit, in order for it to work, we need the argument of my trig function to be on the denominator. Okay, we have a 7x here. Now, does 7 times 0 turn into 0?
Yeah.
Yes, so it's still approaching 0, so we're good. But in order to use the limit formula that we had, we need a 7x on the bottom. How could you get it there? We have an x already. What do I need on the bottom? A 7. So we know that in a fraction it's legal as long as you do the same thing on top and bottom. So I'm going to multiply by 7 over 7. So that's 7 times the sine of 7x over, on the bottom, I'm not going to multiply my 4 and my 7. I'm just going to write this as 4 times 7 times x. Now here's why. We know that when you have limits, if you have coefficients, you could pull them out in front, right? We want this 7x we can't do anything with, so we need this 7x to go on the bottom. That means this 7 and 4 are extra. I don't want them, but those are just coefficients, so you could pull those out in front of your limit. So now, this part all turns into 1, so you have 7/4 times 1, which is 7/4. So on these problems, to simplify these limits, we will introduce, we may have to multiply by something on top and bottom. Coefficients we can pull out, we have to leave it in the form sine of something over that something. Then that limit can turn into 1. Is everybody okay with that one? Let's look at this one. All right. I can't just plug in 0 because I get tangent of 0 divided by 0. We can't simplify that. I don't have a formula for tangent. How can you rewrite tangent? So that would be sine of 3x over cosine 3x, all divided by x. We don't like to leave a fraction within a fraction. This is like x over 1, so if you flip and multiply, you get the sine of 3x over x times the cosine of 3x. Everybody still with me there? Now, what I'm going to do is separate this limit a little bit. I want to get rid of this sine 3x, I need it to be over 3x. So I want to keep the x there, but I don't really want that cosine. So I'm just going to pull that out to the side. So I haven't changed my problem, I just kind of separated that cosine off from the bottom because I don't want that. What do I need on the bottom here?
3.
A 3. But if you put a 3 on the bottom, you have to put it on the top as well. Now, would it be okay if I put the 3 on the top in this fraction and then the bottom on this one? I put a 3 here and here. Don't those 3s still cancel out? Okay. So I'm kind of skipped a step where I multiplied it on the same fraction and then pulled that other one over to the top. But is everybody still with me? Understand that this is equivalent? Now our limit rule says we can do the limit of each one of these and then multiply those answers together. The limit as x approaches 0 of sine 3x over 3x would be 1. Times over here, 3 times 1 is 3, over cosine of 0 is
Wait, why are you doing 0?
3 times 0.
Oh, shit.
0?
Well, add
Oh,
0,
cosine.
cosine would be the square root of 4 over 2, so it's 1.
Yeah, I got it.
So my final answer is 3.
For you, ACT.
Oh my god. I'm already taking shots now.
You took shots first.
I said, did you mess up?
That was real funny.
Any questions on that one?
Yeah, I was 21, so 20. So, like 1 or 2 lower than
You guys need to, we need to have like an incentive system for being nice to each
So
other.
I'm saying.
They're in a therapy session. He started that one.
I'm like,
Yeah, he said.
You know, yeah, it is.
Distribute the square.
Okay, so this just means sine squared theta. What does a square mean? There's 2 of them. So I'm going to write this, that means there's sine theta times sine theta. And on the bottom it's theta times theta, right? So if I pull apart these fractions, that's sine theta over theta times sine theta over theta. Well, what does sine theta over theta turn into? 1 times 1. Bless you. Thank you. And so we just get a 1.
did you even have to like do all that? You just see it.
Now, another way to do it would be, say this is sine theta over theta squared. So then you have 1 squared, which is 1. Can I just plug in? No, because we are getting 0 over 0. So what do we do? Kind of like example 11. What did we do there?
Just, like,
Split them up already?
Yeah.
Cosine.
Let's split them up. We don't want that cosine, so we're just going to pull it over into its own fraction. So we have the sine 2z. Do we want the z to stay with the sine? Yeah, because my goal is to get sine 2z over 2z. And then my cosine 3z would just come over here. All right. Now, for this to work, I need sine 2z over 2z. So if I'm going to put a 2 on the bottom, you need a 2 on the top. And I don't want it in the first fraction, so I'm just going to pull it over here in the second one. So, as z approaches 0, sine 2z over 2z would go to 1 times 2 over, what is the cosine of 0? 1. And get 2. So what would we do here? Mm-hmm. So sine 3 theta squared means you have sine 3 theta times sine of 3 theta. Theta squared means you have theta times theta, and you still have that cosine. So what should we do? Split the fractions. So we have a sine 3 theta. We need that to be over 3 theta, so I'm going to keep one of the thetas with it. I have another sine 3 theta. I'll keep the other theta with it. And then I have a cosine theta on the bottom. So for the first one to work, what do we need? A 3 on the bottom, so that means we have to put a 3 on the top somewhere. I'll just do it on my last one. Okay, so this first one's good. What does the second one need? A 3 on the bottom, so I need another 3 on the top. Now we can do our limits. Sine 3 theta over 3 theta would go to 1 times 1 times 1 times 3 times 3 is 9 over cosine of 0, which is 1, and we get 9. I want you guys to try the next one. So what does this one need? 2. I have to put it on top and bottom. So the 2 on the top we don't really want. You can either separate it out to the side, like a 2 over 1 here, or pull it out in front, either way. So then you have a 2 times limit, theta approaches 0 of sine 2 theta over 2 theta. And this limit would go to 1, so 2 times 1 is 2. All right. This one needs a little work. What are we missing here? We have a sine 2x that would have to be divided by 2x. We have a sine x that would have to be divided by 5x, right? I can't just evaluate my limit because I get 0 over 0. So does anyone have any ideas? A couple different approaches we could take.
Could we split them up and then do it?
Okay. So you're saying make it sine 2x just like over 1,
Yeah.
and this would be a 1 over sine of 5x. So side note, since we're doing it this way, I might talk about the fact we have this theorem so far, but it is also true that the limit as theta approaches 0 of theta divided by sine theta goes to 1. So the reciprocal also works. So if I had 5x over sine 5x, that could still turn into 1. All right. So first of all, what do I have to get on the bottom of this? We need a 2 and an x. So if I put, let's just start with the x. So I could put an x on the bottom, but then you would have to put an x on the top, right? So let's just do the x on the top and this one. So those x's would cancel, so I haven't changed my problem. If I put a 2 on the bottom, we have to put a 2 on the top somewhere. Do I want a 2 in either of these fractions? So let's just go out to the side to a third fraction and put that 2 on top. What does this one need? A 5. If I'm putting a 5 on the top, to cancel that, we need 5 on the bottom, so we could just come out to this one, put a 5 on the bottom. So now we've got it. Theta goes to 0, sine 2x over 2x would go to 1, times 5x over sine of 5x would go to 1, times 2/5, that doesn't even have an x in it, so that would just be 2/5. So 1 times 1 times 2/5 is 2/5. You guys try the next one. See what you can back here. We have x times cotangent is cosine x over sine x. All right. I'm going to regroup these things. I am going to flip the x and the cosine. So I'm going to make this a cosine x over 1 times x over sine x. You guys all agree that that's legal? If you multiply it, we still get the same thing. If I evaluated this limit, cosine of 0 is 1, divided by 1 is 1. This one, 0 over sine of 0, that limit says it goes to 1. So we have 1 times 1, which is 1. I'm going to do one more bonus example. It wasn't on here. Let's do the limit as theta approaches 0 of 1 minus cosine theta over theta. Let's do over theta squared. All right. Any brilliant ideas here? We've been trying to use the sine theta over theta. I don't really have anything with cosine. What could we do if we want to somehow get this into sines instead of my cosine? And the reason, again, why we can't just plug in, if we put in cosine of 0 is 1, so 1 minus 1 is 0 divided by 0. That's why we can't just evaluate the limit. I need to multiply by something. Yeah, let's do that. So if we FOIL the top, we get 1 plus cosine and minus cosine drop, minus cosine squared theta. The bottom, I'm not going to multiply this out. just going to leave it like this. How does that help?
The 1 minus cosine squared can turn into sine squared.
Uh-huh. And now we can evaluate this. If you wanted, you could separate these. Sine squared means you have a sine theta times a sine theta. Theta squared, so we have 2 thetas, so you can put one of them under each of your sines. And then we still have this 1 plus cosine on the bottom. So sine theta over theta would turn into 1 times sine theta over theta is 1. This, if we plug in, we get 1 over 1 plus, what is the cosine of 0? 1. So we get 1/2. May or may not have something like that on your quiz tomorrow.
Monday.
Or Monday, yes. Waiting to be determined. I want to give you guys a chance to try some of these. So that's all I have for this lesson. Your assignment then to add to the other 2 days is at day 3.